Okay, in this video we need to talk about the idea of empirical formula and molecular formula. So to start out with, I'm going to show you an example. For example, C2H6O2 is the formula of vinegar, acetic acid, same idea. Okay. C6H12O2 is the formula of glucose. Okay. These are very, very different things. Glucose is essentially what your body, anytime your body eats carbohydrates, it breaks this down. If you ever eat like simple sugar, like sugar syrups, this is usually what it's made out of, like high fructose corn syrup. Glucose is the syrup part. Okay. Vinegar obviously tastes really sour. They have very, very different chemical activities in the body. Okay, or they just have very different chemical activities. Your body can taste the difference. These are both molecular formulas, which I guess I'll label. These are molecular formulas. Oops. This is also a molecular formula. This is what we're used to seeing. Molecular formulas are the more useful version of this. The idea of empirical versions is we just need to know the relative version of each, the relative amount of each of the elements. So all of these numbers can be divided by 2, and you would get CH3O. Okay? You would basically have to divide each of those down. This is the empirical formula for this. The empirical formula is the reduced version. For this one, we would divide everything by, oh, that's right, that's C6H12O6, I wrote it wrong. This one, we could divide everything by 6, and we would get CH2O. So obviously these have different they have different empirical formulas also, but the idea is the same, that each of these can be broken down to simpler versions. And also the idea is to get from, if you know the empirical formula and you know how much to scale everything up by, you know what the scalar factor is, you could multiply all the numbers by that number to get the molecular formula. So let's try an example where we know the weights of a compound, like the weights of each of the elements in a compound, and we want to know what is the empirical formula. So here's an example. We have a compound, and basically we have 17.5 grams of an unknown salt. I mean, we know what the elements are, but we don't know the formula. We know that if you break it down, 4.32 grams of that are potassium, 6.09 grams are manganese, and 7.09 grams are oxygen. Okay, so what we want to know is, what is the empirical formula? There is a process to this, and it's kind of tedious, and I apologize up front. Okay. So the first step is basically we would like to convert this to each of these to moles. So I guess I'll try to write this in a different color here. Step 1, you're going to convert grams to moles. Okay, so for 4.32 grams of potassium, you're going to convert from grams to moles using the periodic table. Potassium's molar mass is 39.098. That will get you moles. So we take 4.32 divided by 39.098, sorry, 0.98, and we get 0.110, I guess 3 sig figs, 0.110. Okay. We do the same thing for manganese. Manganese, the value is 54.938. Okay, and what we're going to do is we're going to take 6.09 divided by 54.938, and I got 0.111. That would round up slightly, but they're really similar numbers, obviously. And then we do the same thing for oxygen, which is 15.999 grams per mole. 7.09 divided by 15.999. Okay, and I got 0.443. Okay. What we are looking for in the end is not moles. What we're looking for is these nice whole numbers in the simplest form possible, like in a 1 to 3 to 1 ratio or a 1 to 2 to 1 ratio. We want to know what is the ratio of these things. So, step 2 of this is basically divide by whatever the smallest number is. Okay, so 0.110 is the smallest number, so we're going to divide by 0.110. We are looking for nice whole numbers here, so it should work out to reasonably nice whole numbers. So 0.110 divided by 0.110 is 1. Okay, 0.111 divided by 0.110 is also essentially 1. And 0.443 divided by 0.11 should come out to 4. So this is our formula. K, M, N, O, 4. So we're gonna have 1 potassium, 1 manganese, and 4 oxygens. And this is the empirical formula. It also happens to be the molecular formula, but we don't know that from this. We just know this is the most reduced version of this. Okay? All right, thanks.